Hello, everybody, and thank you for this Break to Educate series. Hope that everybody can hear me. See, we had a good turnout today. So thank you so much for attending this. I'm going to try not to call it Lunch and Learn. I call it Break to Educate instead. I know some of you guys have attended our Lunch and Learns before, so this is kind of like a something similar to that, except that in this one we will not just work with the Solidworks core product, but we will actually play around with some of the other neat features. And today we're going to talk about the simulation package that comes with the premium. So it is just like a Lunch and Learn, but it's going into some of the more advanced topics than just the core Solidworks product. So I hope everybody are comfortable and ready to jump into our topic today, what is the simulation package. So let's go right into it and deal with it. So in the simulation package, SolidWorks has a lot of different kinds of simulation coming with it. So if we just jump in here and we kind of like take an overview of what SolidWorks has right now, you will see that down at the bottom we got the standard tools, and then we got professional, and then we got the premium version. And what we're going to talk about today is really about the simulation portion of what comes with the premium version. Really what have happened is that some of our customers have asked for us to do something like this, talking about the SolidWorks simulation in premium, the statics study. And I'm looking at the list of the people we have today. I know some of you guys don't have simulation today, but I'm wondering if it could be useful to have this. Other people have the tool but don't really use it. And my thought today was kind of like giving an intro into how to use the tool and really where the SolidWorks simulation really kind of like comes in. So SolidWorks simulation falls into actually a bigger family of simulation tools. So this is what you get with the premium version of SolidWorks. You get simulation static, and you also get some motion. But it is actually out of a bigger family. So this is what we have here is these two motions, but there is actually also an add-in that goes on top of that is called Simulation Professional, where you get into some more neat tools when it comes to FEA, buckling, there's drop tests, so if you drop something, what's going to happen to it. There's a lot of different neat things, fatigues, and so on. And then there's also simulation premium. So now we're like the third up there where we actually get into non-linear product. But what we're going to concentrate on today is the statics, and we're going to talk about it with parts and assemblies because I think it makes sense to do it that way. Just a kind of like an intro into what is it about and how is this tool working in here. So not really too much, but the other tools, contact us and we can definitely talk more about that. But this is not meant as a sales presentation. This is more, a click by how does this function. Kind of like made me, talk about what is the goal? What is the goal of simulation? And that's what we're talking about most of the time when we're talking about FEA. Where are we trying to go? Well, the idea is that we have our 3D models inside SolidWorks, and the neat thing about it is that the computer knows there's something there, right? And we can actually utilize that 3D model to find out information about how our parts are gonna work in certain scenarios. So that's what we're going to try to achieve today. So the goal is to before you have to do prototypes or some of these what ifs, that we can actually go in and by using FEA tools we can make it cheaper, faster, and better. I like to bring this example up. It's actually borrowed from our friends right up north of us in Canada. These two brothers who like to do mountain biking, and really what they were trying to do was creating equipment that could last longer than other equipment on the market when it comes to bicycling. And they were, a perfect, they already had SolidWorks and coming from a 2D background, and it just made sense to go in and using an FEA product to analyze that. So what can we do with SolidWorks simulation? Well, what we can do is we can take a part like this, and we can very quickly get results like this. We can find out what is going on with our parts in the working environment. That's where really, simulation comes in. And of course, it also works if we want to take it to one step further, like we're going to do today, and say, well, what happens when we put it with other components, because that can kind of like matter, and we can get those information back. So let's jump into SolidWorks, because that's where we like to be anyways, right? And just look at this bracket here, pivot bracket that I have, and talk a little bit about what we have. So we can start out on kind of like a part level, because in SolidWorks with the statics analysis, we can do it both in parts, and we're going to do it in parts, and we're going to do it in assemblies today. So I want to kind of like give you a quick idea about how the tool really functions. What is kind of like the clicks by clicks when we're working through this? What is it we see, and how is the interface working, and how easy is it? Because SolidWorks simulation is a little bit different than some of the other simulation products out there, in the manner that we are running right inside the same interface that we are modeling our parts up in. So with some of the, there's some very big simulation softwares out there, ANSYS and Algo and other ones, but the disadvantage with those is that normally somebody models up the model, and then they send them off to the simulation guys, and then a week or two later you get your results back that your part failed. With SolidWorks, we can get 90% there of what some of these very expensive packages can do. But as you will see today, we do it right inside the interface. Right as you're designing your part, you can be like, hang on a second, let me just check and see how these things are going. So the way that it works is simulation is an add-on. So you can go in and you can turn on your add-ons. You can see right in here we have simulation. And when I check it, you will see I'm going to get another toolbar up here. So it's fully integrated inside SolidWorks. It does all this work right inside SolidWorks. And what we can do is we can start what we call just a new study. So this is a standard SolidWorks file. We have the feature tree. And when we create a new study, we can choose from different ones. Well, if we're having the premium version, what we're talking about today, you will only see static. But as you saw on the slide before, the SolidWorks simulation family is big, and you can really do a lot of very neat things in here as you go on. But with the SolidWorks Premium, you get the static, and I turn that on. And really all what happens when we turn on simulation is that we get a static tab down here. So at any point we can jump back and forth between our feature tree that we're familiar with, and now we got this first static study. And everything is really easily integrated in here, and you will see over here that this menu is very easy to work with. So the first thing, just like inside SolidWorks, we can start from the top and work our way down. So the first thing we might want to do is something like a material. Well, I already have a little green check mark because it actually already saw that I applied a SolidWorks material in here, because that's what FEA is using. It's just using the standard SolidWorks materials you have in there. You can create your own material, custom materials, where you can put your own parameters in. It's fully customizable in there. Another thing we might want to do after we set that, all right, we have our material in here, is how we're going to hold the part. And what is really neat about SolidWorks is that it lets you be lazy, if that's in a good way, in the manner that inside of SolidWorks with FEA, we can set up studies very quickly. We can copy studies, what means that we can kind of like just get some general input, and then we can fine-tune it as we're going along. So with this pivot bracket here, I might just choose that I'm going to add a fixture. I'm saying that this one's going to be fixed here and here. And really what I'm saying is to SolidWorks is that's where this part is going to be located with that. You will see that there's a lot of different options in here. Maybe it was not just fixed. Maybe it actually can roll along those faces, or they can actually also pivot around certain faces. And there's a lot of different options in here on how you can do that, almost like working with something like the mating tool. But I'm just going to say fixed here. And then I can choose what kind of load. Now I have this bracket installed here. Maybe I want to have a pin going through here and I want to figure out some load. So I can actually go in here and say I'm going to create a load. And in my case, I'm just going to select a false. And again, you will see everything is Solidworks. So this is very quickly to set up. And I'm going to say, well, I'm going to apply a false in here. And you will see that I get the feedback from the arrows. But I actually want it in a certain direction. So I could just say I'm going to select it in a certain direction. Again, everything is familiar with SolidWorks, and I can actually use SolidWorks. So I can say in the direction of this plane, and just like that, I can apply 100 newtons to this, or a couple hundred pounds to this, and I have applied that right to that face of that hole in the direction of my top plane, because that was what I used. Now, the next thing you got to do with simulation is mesh it, and SolidWorks is pretty easy. We can just actually go in and just say we're going to run this, because this is kind of like my first study, and it will mesh it automatically, and you will see how fast it came up with the result. So I just meshed and run that part in like literally seconds, and already now I can start getting some feedback done. That's really all I needed to do to set up this part and just run a quick study on it. So I set my materials, I applied a fixture, applied a load, and I ran it with a mesh, and already now I can go in here and I can actually see, get some information on where, if I do that, if I apply that load to here, where is my stress is going to be on my part. I actually have my von Mises stress here. Of course, all of these things can be very quickly customized right in here. We can go and we can change it if we want to show it in another format. We can show it in another format, and it will automatically update if we want to do the megapascals and all these things. So that's very easy to work with. We can completely control how the graph looks like. But out of the box, it gave us a von Mises stress. And let's also look at something like displacement and see what was the biggest displacement. You can see here that we got in millimeters. That is, the part gets displayed by its red, 1.3 millimeters. And we can also apply strains, or so many people want to apply a safety factor, factor of safety, and that can be done right in here too. So you can add all these different analyses. So very quickly, you can start getting an idea about where is this part going to break. And in our case here, we can see that we have a corner up here that is a little red. SolidWorks gives us a ton of tools right at your fingertips to analyze your part in here to go ahead with that. If I go in here and I right-click, I could do one of my favorites, like an ISO clipping. Really what it does is it kind of like takes this part, and I can see on the scale where is my stresses. So you can see here to the left, I kind of like roll up and down. So it really gives me an idea that I can really zoom in and see where is my stresses highest, and give me that idea. So very quickly you can go ahead and kind of like get that rough idea. Now, simulation is all about the data. It's all about the feedback. What are you trying to get out of this? And with SolidWorks, you can then, when we look at this, we might say, all right, this is what we were looking for. We were looking for where is the area where it's going to, where it's going to strain the most, give the big stresses. So it's very quickly from in here to, if you want to get further down, you want to see things a little bit closer. You want to get some better ideas about what really happens on the part. And really all I can do, if I want to keep my studies, I can just right click and I can just duplicate my next study here, give it another name, and call it fine, for example. And now I have two studies. I have the study that we just ran, and now I got a duplicate of it that has another name. So now I might go in and say, well, so I realize that we got some results, but if we look at the mass in here, so I'm just going to right click here and say show the mass. This was what SolidWorks kind of like default to mass. Now I maybe want to get a little bit finer result of what actually is happening in this area. So simulation is using these meshing parameters. Well, in here we can actually go in and we can create mesh control. What means that now I can go in and say, well, I know that this corner is getting strained with these other corners, and I want to know really what happens. So I can turn a finer mesh on, and now I can actually create a finer information of that area and get a better result. So if we go in here now and we show the mesh, you will see that my mesh on this test got a lot finer in those areas, meaning I'm getting a little bit better result because I refined the mesh. But you can see how quickly I'm actually able to run these studies. So now we can see that probably our numbers have changed a little bit from what we had before on the fine study versus the other study, just because we made a little finer mesh. And I'll just change 0.2. But because we made a finer mesh, we now have a little bit of result. So you can work with that. You can also go ahead and say, all right, so we know that we now have this, we got a little bit better result. What about inside Solidworks? We like to work with configurations and different variations. What would happen if we change things? And this is where Solidworks really is strong in this area, because we can get this feedback. So I might go into Solidworks here, and let's just create a new configuration. So I'm just going to go in here and Control-C, Control-V, and I have this copy default here. We could change the name, of course. This is just standard Solidworks, and say bigger radius. What will happen if we add a bigger rad to these inner corners where we know that there's an issue? All I'm going to do is I'm going to just go in, I'm going to create that other configuration. So maybe I go in here to my filter tool, and for this configuration I make it, let's make it big, make it tan, right? So now suddenly our Solidworks part have changed here, right? So let's go back into our configuration. Now you will see that in our study it's now gray. So I'm just going to make another one where I'm going to call this one bigger rad, so it kind of like fits in. So you can see how quick I'm actually creating new studies in here, and I can go in and I can run that study, and now I suddenly get one with a bigger rad in here. And if we go in here and we look at the show the mesh up, we will see that we're still containing that fine mesh, right? And just in a matter of minutes, my numbers are changing because I'm now testing out with different meshes and different and different strains. So now you will see that in this case we had 5.7, and if we go to our bigger rad that we just created this change here, we can now see that our stresses have changed from 5.7 to 4.1. So that's kind of like the idea behind with SolidWorks, how quick we can go in and get this feedback on this part and get results that we can see what is the different effects for the different parts. So that's kind of like the idea on SolidWorks' portion in a part level, how we can very quickly go in and run these analysis. And I have them all three. The first one we started out with, the one where we actually made the mesh a little finer, and then the one we just ran here where we actually physically went in and changed the model. And like I said before, where there's something like, we can go and we can animate it so we can get a good idea about what's happening. We can go in, I used before the ISO clipping that I have a big favor of, because it really shows me exactly in what magnitude the stress is happening. And even down to a point where we can go in and probe around the node. So we can really go in here, and wherever I'm clicking, I get the feedback right back there of what is happening on those. So SolidWorks has all these functions right in here. So on a part level, it is really quick to get this information. But that's all good and great, but many times our parts don't fit, are not just single parts, right? They actually sit on an assembly, and other things can affect it. So that's where SolidWorks, with the assembly level, with the static assembly level, really, you can take it and kick it into gear. So I might look at this part and say, all right, let me throw this one into an assembly. So I'm just going to make an assembly from this, insert it in here, right? So now we just got this part sitting inside an assembly. And what is neat about doing these FEA analysis right inside of this this environment is that we really we can play around with different things. And since we're inside SolidWorks, it's very easy to kind of like work with things. So I might say, all right, I know that there's a rod going through these holes, it's going to pivot over, and that's maybe actually where the load's going to be. The load is not going to be just on that little area of the part. It's actually going to be out here. So inside an assembly, well, if you are familiar with SolidWorks, you know that we can make virtual parts in here. So I can just make a new part right inside this assembly, and that's exactly what I'm doing here. So I have an empty part. We can go and we can work with that, right? So I can actually go in to this part here and open up a sketch on this face here, and I'm just going to do like a convert entities. So I get a sketch, and let's extrude that one out. So I kind of like make my rod right now inside of this part. So now I've kind of like created this rod. Now the whole thing is kind of like the same, where we can apply the load to it. Now what I need to do to this rod is I need to place I want to place the load out here in the end. I don't want the load to be on the entire face. So one of the things I'm going to do is I'm actually going to create inside this part here, I'm just going to create a sketch that I can go ahead and just break this face off. So I'm just going to go normal to and create a little sketch line here, and then I can use SolidWorks function like split line, and this quickly here I have now broken that face up to its own face. So what I can do now is I can apply what is the real world, right? Is I'm actually applying maybe the pressure out here and want to see what happens to my parts. So I'm going to do the same thing as I did before. I'm going to go into simulation here, and I'm going to create a static study, just like we did in the part level. And it's kind of like the same way. Now, you will see that now I actually have multiple parts. I never assigned a material to this part here, so we can do that right from in here. So again, the materials we're applying are the SolidWorks materials, right? So I might go in and say that that's a stainless steel part. So now I've applied that. Now, one of the things we have to do inside of when we're working assemblies is we got to tell SolidWorks how these are sitting together, right? I mean, are they mated or whatever, but we also, from an FEA standpoint, have to say how are you going to treat these. And we do that by calling this a contact set. And it's really easy. The way we work with it is, can it penetrate? Is it bonded? That's kind of like, is it kind of like fitted together, glued together? We can actually also go in and do string fits and things like that. In this case here, I'm just going to say bonded. So I'm going to say that this pin, this face, is bonded with those two inner faces of our pivot bracket. So again, I'm using SolidWorks command just to go in and select these areas. So right click, select other, and we can actually go in and select those pivots. So we just set to SolidWorks how these fit together. And then again, just like before, we got to go in and say, how is this part hold? And we could go ahead and say that we're going to hold it on that bracket too, and we can insert that. And then we got to apply our load. What is the same one as we did before? Now you can see that just in the static, we can actually do different things. We can apply gravity. We can apply that there could be a temperature of this part that could affect the materials and things like that. I'm just going to apply, just like I did before, I'm going to apply a force to that face, and it's going to be the top plane. I'm going to have a direction on it of, again, we could do the same 100 newtons because that's actually what we were kind of like looking at. And if I just run the study like we did before, just run it with the default mass, you will see again how quickly we are getting feedback back in here on that when we apply that. Now we will also see that our stresses are really now a lot lower because, well, the first one I did on the part was not really true, because if the pressure is going to be out here, it's not really going to affect this part that much. But we can see that, you know, it's still in the same area. So you get all the same functions when you're working inside an assembly as you're working inside of a part. We're working from the top, just working your way down, applying the different stresses. And you can, of course, apply more stresses. So if I know that this part is actually being pushed from other directions too, I can just add, you know, another force and say, all right, well, we're also going to have a force that's going to go from this face that maybe goes, you know, in another direction. I can actually go in here and say that I want it to go in that direction. Maybe I want it to go in that direction, and I can apply some other pressure in that direction. And just like that, Solidworks will go in and we can run that study too, and now we will get another effect on, you know, what is happening to our parts. And then, by the way, all these, you know, all this solving that I'm doing, you're seeing me doing it in real time. So you're really seeing how fast it is. It's not like something that we have to sit around and wait for and work with. And just like in parts, we have our configurations to help us to work with it. So we really get these results very quickly. The displacement, right? We can now see that our displacement is very small in this area. And again, you know, we can go and we can take a closer look at, you know, where is, in this case, we're looking at displacement. You know, we can see about where is the part actually being moved. You can also do things like going in and actually do a section clipping and kind of like, you know, drag your thing through it here and get feedback like that. So we have, you know, pretty much any data you need to grab out of here, you can work with. Also, another thing I just quickly wanted to show as we're talking here is that, you know, what you've seen me do so far is that I've taken an approach in the beginning where I was like, all right, just give me some feedback, and then I have really just narrowed it down, making the mesh finer or work with it in that regard. Solidworks has a lot of neat tools in here we can work with. I, for example, have to this point only fixed these two areas, but in the real world you can see that I actually have some bolt connections in here. So this one is actually bolted to something else. Well, maybe I want to see how that is affecting my whole scenario. So again, I'm working right now, and I can just go out and I can grab some kind of part that actually fits with that, and bring that in. And maybe not insert component. One open. Oh, okay. Let's I might get a little, because I'm projecting here. Let's get back to our desktop here. It's becoming a little bit of a mess. Sorry about that. And if we open this one up by itself, maybe. All right, so I have this plate here, and let's see if we go in. And for some reason it doesn't see it. That's interesting. That's always good when you're doing things live, huh? So, well, that's not going to stop us from doing something. So let me just, that is very interesting though. Let me open up another part. I'm not going to see it. So we have this part here. Let's save that one as our sim test. Haha. I'm going to try to get it to work somewhere. And let's see if we can bring that part in. That will do it. All right, so that's apparently something in my, that's not working. All right, so what we're going to do is we're going to take this part here, and we're kind of like going to call this one like our dummy part maybe, and just go in and insert this part. I'm just going to mate it in. So there's some really nice mating tools recently, right? So we can go in here, and what I can do is just to show you, if I go in and I edit this part in content, I was going to say about the assembly, sure. So we're going to do this in content, and I decide to put in some hole wizard holes. So I'm going to go in here and select, that's probably all right. And let's select, put in some M10s here. Okay. So now we got some hole wizard holes in that block that I just put it in here. So we got these hole wizard holes here, so we can see those. So this part here, to make this more realistic, I may want to see what's happening to these brackets when I'm in here. So what we can actually do is, let's just make it a little bit thicker. Oh, of course, it's the other way. Nah, it's going to work for what we're trying to do. What we can do is we could actually go in and make a study where so let's go in here and let's just duplicate this study here. And we're going to call this one bracket mounted. Okay. So now on this study, actually, I got to go in here and I have my other part here. It already has an A2 steel assigned to it, so that's good. I got to create a contact set for how these are mounted together too. So we can go in and we can add that contact set. But that's why you will see that we actually here have other ways, because up to this point you saw that I fixed this plate, but this plate here is actually not, I don't want to fix this bracket, right? It's actually going to be mounted with these hole wizard holes. That's how it is in real life. So if I go in and I instead fix this part, say this thing is fixed, now I can actually go into SolidWorks and I can say, well, I want you to add a bolt, and this is going to be, one of these bolts here, and I can go in and select this. And actually, if I select these, the hole wizard hole is actually smart enough to know the size. And I can go in here, and now I can actually tell you exactly how this part's gonna react with the bolts, because that's different when it's mounted like this. You can even we can add some torque in here if we wanted to add some torque to these bolts. So now I can go in and I can create a study where I can go in and say that I have bolts sitting, I want to study where I have 4 bolts, or, maybe I want to find out what happens if somebody, only tie in 2 bolts. What if they forget to put all 4 bolts in? What is that going to do? What is that going to do to my study? And I will be able to find out exactly what that's going to do to our parts here. With that. And again, you can see the solving time is just so quick. And now we can actually see what happens with the bolts, where the strain is. So we can actually see we start getting some effect on this one before we get any effect on this one when we tie it down. So suddenly we have, taken more things into consideration, not just, as we did on the part level where we saw this happening here, but actually now to the point where we have added the bolts in. And as you can see here, you can do a lot of different things. You can do, welds. You can, maybe it was a bearing we saw before, how we had the bicycle things in there. And all these things are right in here for you to add in here and set these studies up and get these information back here. So if you already have SolidWorks Premium, you have these tools available to go in and create these studies, and very, very quickly you can get some very good feedback on what is actually happening to your parts in real life. We all know that when you're working with, when worked out in industry, we always had a tendency to just beef it up, make it stronger, but that costs more money and it can be complicated. If you already have Premium, you are already there, right? You can run these studies and get some very, very good idea about what you need. And it comes with the report tools too, so you can actually go in and we can actually create reports that can be saved with the part and really, give us a good idea about where our design is. So if we ever need to make a change of this part here, we have those options to go through, and we can see how did the last part do, and you'll actually see it grab some screenshots and different things as it's going through this process. So a couple of things I think to take away from what we did here was how quick we could do it on a part level, just to kind of like get an idea about what was happening. We could go in, we could change the radiuses in there and see how that affected it, and then throwing it into an assembly where we could actually get a more true idea about what happens with it. As you can see, the report in here is very detailed, gives us all the different feedback that we could really ask for in regards to that. So if you have the tool, you should definitely do yourself a favor to go through it and set it up this way. And really, like I said before, starting from the top, working your way down, setting up your materials, setting up your connections, fixtures and loads, and then get it messed in there. There is also, with the simulation tool, there is also some great tutorials in here that is a really good way to get started. And then, of course, us at CAD Dimensions, we of course also have training classes that can take you a lot deeper into the different products. But again, it's very quickly to create studies and get these different studies in here. See that data, our quick static, the one where we change the mesh, the big red, and then when we throw it into an assembly level, where we actually also in there can do a quick study that gives us an idea what happened when we added the pin, and then what happens when we actually mount the bracket with the bolts that we need, or with the pins that we need. So it's one of these tools that many people have that people haven't used, and I hope that this really this 40 minutes gave you an idea about where this tool can kind of like fit in, where it can kind of like take you, and definitely put your hunger on that you can use this. So again, going back to straight line, the bicycle manufacturer, it really just it changes things when you can do these visualizations very quickly on the computer, and the owner here, who really I think put it great by saying that this really gave them an option to take their designs and test them quicker before you really have to go out to the field. So again, going back to what really is the goal, because when we talk of simulation, that's what we already talk about. What is the goal? Well, again, the goal is to really give you this information right out of the software. The software knows that there's something there, and we can utilize that information as engineers and designers to get you there, and really end up doing it better and faster. So again, these Break to Educate, really an idea to give you a little bit of the mouse clicks and show you, how you can set up your studies. The tutorials inside of the simulation are really great and good to get you going. And if you just start from the top and working your way down, I think that you will see that you can very quickly set up your studies and run them. So that was really all I had planned on showing you today. I hope that you find this helpful and this something that you can utilize to your advantage. If you have these tools, and for you guys that I know out there who are considering, I think that that this will be something that you can find a value in. If you have any questions, you're definitely more than welcome to contact me, Lars at caddimensions.com, Lars at caddimensions.com. Of course, we have offices all across the state, so don't hesitate giving us a call if you need a little bit more detail. Thank you so much for attending, guys. Really appreciate it. If there's any questions, I'll let you guys ask them, and you can do it right in the question area, and we will answer them. So let me just take a look here. So I can see we got a couple of questions. So yeah, definitely I can bring up the slide and talk a little bit more about that first slide I had about what is in the the different packages are, just so we can talk about it quick. So this is the overview of SolidWorks. So you have standard, and then you got professional that have all these things, and then premium up here, where what we were talking about today was the simulation, static simulation in here. And actually SolidWorks is coming out with an offering. I don't know, I'm not sales, I don't know all of the details, but you can actually add a simulation package to standard packets, so you don't have to go through the professional and the premium if you don't need some of the other tools. But yes, that's the static that we talked about today. And really, when you're looking at it, it's part of that family. So this is what we did today, but there's a lot of other things in here that gives you that value of adding that back. Okay. And a question about being inside assembly, and I made it, but then I added the bolt connectors to it. Yeah, so in SolidWorks we make things together, right? But it's kind of like a refrigerator magnet type. You put coincident, coincident, coincident. You saw me do that. But the simulation software needs to, you know, it's almost like doing physical testing in real life. So in the beginning, when I just fixed the faces, I was kind of like cheating. I was just kind of like saying, yeah, let's just do this just so we can get some result. And then in the end, I says, well, in real life, it will actually be bolted in here, and let me find out what happens when I bolt it in there. And you know, my scenario was I only put 2 bolts in here versus the 4 bolts that was here. There's actually also a couple on the top. So simulation will give you those feedback. And if you wanted to add a couple more bolts to test them, you could go in and add them right here by right-clicking and say you want to add the bolt. Or you could say, well, I want a study where I only have 2, and I want to duplicate this study and create another study where I'm now going to add all of them so I can see how it is with 6. So that's one of the things that is really neat about this, that it gives you this feedback. And the solvers in here are incredibly fast. So we have a really great team here too, both in our offices. Multiple offices with FEA guys who definitely will help you, assist you, and things like that. So yeah, so there's a lot of different things we can do here to set this up to be like how it is in real life. You know, if there's certain temperatures is fighting, if there is, you know, you saw I could do the pin as a string fit if that meant, because that will change the stresses, right? And so there's a lot of those things. Okay. So definitely, you know, I can definitely reach out to you guys with, if you don't have SolidWorks Premium, the price of it. Yeah, I can definitely get back to you on that. I don't know it offhand, but for sure, if there's a value in it, right? I mean, it's pretty neat. You can do these testing right up front. Okay, guys. I really appreciate you guys taking the time to sit in on this break to educate. I hope that you got a little bit of value, saw what really you know is in offering when it comes to FEA. It's very useful and definitely something that if you are in need of any testing, look into. Thank you so much, guys. Appreciate it.